Hello guys, in this video we will learn how to convert a decimal number to a binary number and a binary number to a decimal number. It's very easy, so let's get started. Okay, so our topic is binary numbers. First, we will see how to convert a decimal number to a binary number. So let's say a decimal number we have 45. Let's take the example of 45. This is the decimal number. Now, how will you understand that the number which I have written is a decimal number or not? Well, there is a formula called 0 to r minus 1. This is the range 0 to r minus 1. This is the range of any number system. Now, this is called as the base. This 10 is called as a base. It also has another synonym which is called as a radix, right? So this is called as a base or radix. So this, for this case, the base or radix is 10. For decimal number system, the base or radix is 10. And for binary number system, the base or radix is 2. Okay. And here this r represents the radix or the base. So if I am telling that there is a decimal number, so I will replace this r with 10. So it will turn to 0 to 10 minus 1, which is 0 to 9. Okay, so this is the range of a decimal number system. So whenever we are talking about a decimal number system, this is the range of a decimal number. So 0 to 9 is the range of a decimal number. Any number beyond that cannot be in the decimal number system. It's very obvious. The decimal number systems, we only have 0 to 9 numbers, right? We don't have any numbers other than 9, or beyond 9 we don't have any numbers, right? So decimal number system, there is 0 to 9. But if we take the range 0 to r minus 1, if I replace this r with 2 in binary or the base 2 number, I will replace this r with 2. Okay, so 0 to 2 minus 1, which is 0 to 1, or 0 and 1. In binary number system, there are only 2 digits which we use to represent a binary number system, which is 0 and 1, right? Any number beyond 1 cannot be in the binary number system, right? So in binary number system, we only have 0 and 1. Okay, so 45 is definitely not a binary number because we have 4 and 5. These are not in the range of 0 and 1. So like this, we will be able to understand, or we will be able to recognize any particular base's range. Okay, so let's take the example of a octal number system where octal, the base is 8, right? So it will be 0 to 8 minus 1, which is 0 to 7. Okay, so that means 79. If I am taking this and telling this is an octal number, this is wrong. This is completely wrong. This is not an octal number because we have 7. It falls in the range of 0 to 7, but the 9 does not fall in the range of 0 to 7. 9 is not a part of the octal number system. So we cannot say that 75 is an octal number, right? So 79. 79 is an octal number. We cannot say because 79, we have 9 in this number, and 9 is does not fall in the range of 0 to 7, right? So I hope this much is very crystal clear to every one of you. Now we will learn how to convert a decimal number to a binary number. Okay, let me erase all of them. So we will see now what we will see. We will see decimal to binary. So we will see decimal to binary number conversion. Okay. Now let us take the example of a number 38. This is a decimal number and we have to convert it to a base 2 number. So we have a 38 as the decimal number. 38 is definitely a decimal number because we have 0 to 9, and of course 0 to 9 we have 3 and 8. 3 and 8 are does fall in the range 0 to 9. So 38 is definitely a decimal number. Okay, so 38 is a decimal number. We have to convert it to a binary number. How to do that? We will make successive division. Listen carefully. We will do successive division with 2, and we will note the remainders in every case. Okay, if the remainder is 0, we will note 0. If the remainder is 1, we will note 1. Okay, but in every step we have to note the remainder, and we have to go on dividing until we get a 1 as the quotient. So what do I mean by that? Let me show you. Okay, so remember, we will convert 38 to binary. Okay, so let me write it down over here. 38 decimal to binary. We need to convert this. I'm perspiring a lot because the fan is off. Okay, so don't mind. Okay, 38 to the binary number we have to convert. So for that, we will write 38. I hope it is visible. 38. Now we will divide it by 2. First we will divide it by 2. Okay, so 2 times 1 gives us 3, and the 1 is carried to 8, so it is 18. 2 9s are 18, right? So 2 9s are 18. So 2 times 19 gives us 38. And what is the remainder in this case? It's of course 0. So we will note that remainder, right? So 2 times 19 gives us 38, and this remainder is 0. So we will note that remainder. Okay. Now, then again we will divide it by 2. So as I said you, we will perform successive division with 2. Since we are converting a decimal number to a binary number, we will perform the successive divisions with 2, right? Binary. So binary means 2. So we will divide it by 2. So 2 times how much gives us 19? Definitely we don't get 2 times anything gives us 19. It is, so 2 times 2 9s are 18, right? 2 9s are 18, and 1 is the remainder. So we will note 1 over here. Now note one thing, in every case we will get a 0 or a 1 as a remainder. We will not get anything apart from that, because since we are dividing it by 2, in binary number system we have only 0 and 1, right? So 0 and 1 are the only two numbers. So in every case, whenever we will divide the number, whenever we will divide the quotient with, this is the quotient, right? This is the quotient. So whenever we will divide the quotient with 2, we will either get a 0 or a 1. Okay. So 2 times 9s are 18, and 1 is the remainder. We will note the remainder. Then 2 times 4s are 8, right? And remainder is 1. 2 times 4s are 8, remainder is 1. 2 times 2s are 4, remainder is how much? 0, right? So 0. So 2 times 1s are 2, 2 times 1s are 2, and remainder here is how much? 0, right? And we are left with 1. So what I said, we will perform successive divisions until and unless we get a 1 as the quotient. So here we got 1. So we will stop here. We can also perform a last step, which is 2 times 0 is a 0. 2 times 0 is a 0, and this 1 will come as a remainder out. But you don't have to remember this step, because this will make it much more complicated. I hope if you understand this, then it's fine. But I will remove this part. Okay. So till we get a 1, we will go on dividing the number. Now what we will do, look carefully. We will take all this number from bottom to up. So we will take this number, we also have to take. We cannot ignore this number. We also have to take this 1. So we will take the bottom to up all the numbers and we will write these numbers in this form or in this sequence, right? So it's 1 0 0 1 1 0 1 0 0 1 1 0, and this is the binary equivalent of 38. Did you get my point? How to convert a decimal number to a binary number? This is very simple. Okay, so 38, I converted it to a binary number. Now I hope this is very much clear, and I want to keep this video till this much. In the next video, let us see how to convert a binary number to a decimal number. It's not that complicated, it's very simple, but I want to keep the video short. So we will keep it till here. We have seen that how to convert a decimal number to a binary number. In the next video, we will see how to convert a binary number back to a decimal number. Okay. Thanks a lot for watching. If you like this video, do hit the like button, share it with your friends, and do consider subscribing this channel if you haven't yet. Thanks for watching. Goodbye.